ऊपर ऊपर बोलो सर ऊपर जो
So very good afternoon to all. Am I audible?
Good afternoon, sir.
So getting the screen.
Yes, sir.
Okay.
yes sir
So I think in the last lecture we discussed about the multiplication of the vector, which may be a dot product as well as the cross product, where if I multiply the two vector a dot b, then it is considered as a mod of a mod of b cos theta, where theta is the angle between the a and b. But if you multiply the vector a and b, and if your answer is the vector form, then it is considered as a cross product. So we can write down the a cross b is equal to mod of a mod of b sine theta where theta is the angle between the vector A and B, and they are multiplied with a unit vector. Okay, so this is the difference compared to the dot product as well as the cross product. Okay, in a dot product you may be only getting the magnitude part, but in a cross product you may be getting the magnitude as well as the direction, because a of n is basically a unit vector which is normal to the plane which may be containing the a and b. Okay, now see exactly what is the direction of a n. Okay, and already you are knowing the a cross b is equal to a matrix form where small a of x, small a of y, and small a of z, this is basically a unit vector in a direction of x, y, and z. And capital A of x, capital A of y, and capital A of z, it's a components with respect to direction of x, y, and z for the vector a, and similar for the b of x, b of y, and b of z. So if you try to solve this matrix, it's already known, like if I multiply this two and if I multiply, you may be getting this answer. Okay, similar if I multiply the a of for the a of y, you may be getting this answer. Okay, so this is about the cross product. And if you see the a of n, if you see the vector a cross b, where the a of n is basically a unit normal vector to the plane which is the containing the a and b. So where exactly the a of n? Like consider this is a plane, it may be x axis, it may be y, or it may be z. Like a may be located in a x plane or x direction, and b may be located in a y plane. So both are located in a some xy plane. So if you find out the answer of a cross b, so definitely the answer will be in a another plane which is nothing but a z plane. Okay, so a cross b, which is the perpendicular to the plane where the a and b is located, and the a dot b, it's the same plane where a and b is located. So a dot b is in this. What? Any doubt? So let's discuss this part. Now suppose if you see the you have a vector, and if I multiply the dot and cross, so you may be also getting the answer. Okay, so unit vector is basically what? It's a vector. So if I multiply the unit vector, you will be also getting the answer like this way. Suppose consider a of x. A of x basically what? Is a unit vector in a direction of the x, and a of y, it's a unit vector in a direction of the y. If you find out the cross product, then answer is always the remaining axis. It means it is a of z. Similar one, a of y cross a of z will be generate the answer of a of x. Okay, how can I identify this one? Based on this figure. Say this one, the figure A, where a of x and a of y, these are the in xy plane, and the unit vector z, which is the perpendicular to the z, perpendicular to the xy plane. So it's a of z. Similar, a of y cross a of z, the answer is in which direction? X direction, because this is the perpendicular. So it's a of x. And similar, a of z cross a of x, it's the answer in a ay. Okay, so this is required for whenever you are solving some of the example and you have to multiply some of the vector, then this may be required for the multiplication of the unit vector. Okay, so already we discussed this part, this one. Clear? Now instead of the cross product, suppose if I multiply the ax dot ay, can anybody tell me what is the answer over here? Instead of the cross product, now it is the dot product, ax dot ay. So answer is, just see the ax and ay. You cannot find out the dot product for this case because both are 90-degree opposite. if you see the direction of the ax and ay, it will be a 90-degree opposite. So instead of this cross, suppose if I put the dot over here, ax dot ay, then definitely answer is 0. Ay dot az, answer is 0. Az dot ax, answer is 0. Because it have a 90-degree opposite to each other. So it's a some kind of it have a orthogonal nature. Okay, so if the dot product of any two vector it should be 0, then it is considered as a both are perpendicular. Okay, so why you can find out from this one using this cross product. So this is the cross product. Okay, but suppose if I multiply the same unit vector like ax dot ax, okay, so it's basically it's a mode, so it's a same direction where the ax is present, so the answer is maxima, it should be 1. Similar ay dot ay, answer is 1, and az dot az, it's 1. Okay, so this is the dot product of the unit vector with respect to x, y, and z. Okay, now based on this we are trying to find out the projection. If we are taking the projection, then you may be getting the, okay, before we going to this projection, we are just consider this part. This is very easy. Scalar triple product and the vector triple product. Instead of the two vector, suppose there is a three vector is given to you, a, b, and c. Okay, and if I multiply this three vector and the resultant answer is the scalar, then it is considered the scalar triple product. If I multiply the three vector and if you're getting the answer is vector, then it is considered as a vector triple product. Okay. So this is the way to find out the answer. A dot b cross c, and just interchange the position of c and a and b. So these all are generate the same answer. Okay. So how exactly you can find out the scalar triple product? First one is either you can find out the b cross c. Okay, and just multiply with a in a dot product. You may be also getting the same answer. Okay. Same way, instead of this b cross c, suppose if you find out the same one using the matrix form, the reason is if you multiply a dot b cross c, answer is in a scalar form. Okay, and already you are knowing the matrix, it gives me the vector, and if I multiply the another vector, the definite answer is in scalar form. Okay, so if you see the matrix of the initial one where it is mentioned with a small a of x, small a of y, and small a of z. Okay, instead of this one, they are mentioning the capital A of x, capital A of y, and capital A of z. So can you tell me what is this?
The magnitude.
Yeah, it's a magnitude or it's a components in a direction of x, y, and z for the vector A. This is the components x, y, and z for the B, and this is for the C. Okay, so see, all are the some digit or some value should be there. So if you multiply each and every one, definitely answer in terms of the scalar one. Okay, so that's why it is called the scalar triple product. Okay. And the vector triple product can be find out using this BAC as well as the CAB rules. Okay, how exactly they are getting this equation? Suppose if I multiply the b cross c, definitely answer is vector, and a vector which is multiplied with another vector, and it is a cross, so definitely answer in terms of the vector form. That's why it is called as a vector triple product. Okay, so they are getting the try and error method, like they are find out the some combination, and based on this combination they are just subtract this two vector, then you may be getting the similar answer of this a cross b cross c. Okay, so this is called the BAC minus CAB rules. So if the in exam it may be asked the vector is given to you and they are asking find out the vector or scalar triple product. So for the scalar triple product you may use this equation, and for the vector triple product you may be use this equation. Okay, this is the easiest way, like you may be find out b cross c and just find out the whatever the answer you are getting for b cross c, find out the cross product with a, or maybe you are using this one using the dot product, both are the same. So this is called the vector as well as the scalar triple product. Now we are interested to find out the components of a vector in a some given direction. This is called the components of a vector in a some specific direction. This is useful to find out the projection. Hope so all of you are knowing the projection. Projection is basically what? From the any vector to we are taking some distance. This is basically a projection. Okay. So I'm given some of the figure is given to you. You may see the figure A where this is the vector B direction. Clear? And this is the vector A direction. Both the vector are separated with a distance, with a distance as well as the some angle. So right now consider this angle is theta. Okay. Taking the vector B, taking the vector A from this point. Okay. Now from the vector A, if I am taking the projection means a straightforward line to vector B. So this is called the projection. Okay. So this is the important area where we are interested, from this point to the projection at a vector A, which is mentioned with a capital A of B in a figure A. This is called what? This is called the scalar component A of B. Okay. Now see, whenever you are taking the projection, there is a two option. Either you are moving from A to B or either you are moving from B to A. Is there any difference?
No.
Hello. Is there any difference if I'm moving from this to this point or if I'm moving from A to B, from the projection A to B? Yes, it is a different because you are dealt with a vector. Okay. So if I'm moving from A to B, it means you subtract from B to minus A. Or maybe if I'm moving from this to this, so it is a reverse thing. Okay. Magnitude part is similar. See, magnitude are not changed, the direction is changed. That's why it is considered as a scalar component. Okay. So scalar component A of B can be find out using this equation. How you can find out? So A of B is equal to what you are getting. Suppose I am find out this area, this one. You are knowing the vector A and you are knowing the angle between these two. Okay. So what they are considering? A into cos theta AB. Vector A into cos theta AB. Similar to this one. Okay. Because these are the known components. If I know the two vector, I can find out easily the angle, and the vector is already given to you. So these are the known parameters. Okay. Now instead of this vector A, okay, if I multiply with a mode and the direction, okay, so what they are doing, instead of the vector A, they are putting the mode of A and the direction is which one? Direction you are moving from in a along the B, because you are moving in this direction. Okay, that's why see the multiplication factor, it's a mode of AB. Clear? So it's a mode of AB. Now just analyze this equation and can you tell me what is this? Any one of you?
A dot B.
Yeah, it's a dot B, but see, it's not a B, it's a unit vector of A of B. There is some difference. Okay, this is not a
Yes.
B. This is the unit vector of B. It means it's a vector B divided by its a magnitude. Okay, but see, this is the dot product of vector A and the unit vector B, because it is a multiplication of the cos theta term. Clear? So that's why instead of this one, what they are multiply? Vector A dot A of B, where A of B is the unit vector. Clear? So this is the answer of the scalar components of A along the direction of B. Clear? This is the components of A along the direction. Which components are scalar components? Similar way, if I'm interested to find out the vector, now see what is the difference. In this case, you are just interested the distance part. It means this one. Okay. But there's a two option, either you are moving from B to A or either you are moving from A to B. Okay, so see, in this case they are taking the arrow for the figure B from B to A. So this is called at the vector components of A of B. This is only the difference. Okay, so at least if you find out this one, it means the 50% is covered, because this gives me the magnitude, and if I'm moving from this to this, you have to interested to find out the direction. Okay, so the vector components of A along the B, how you can find out? Whatever the answer you are getting A dot B, multiply with a unit vector of AB. But it's a simple multiplication. Remember, it's a simple multiplication. Okay, so just write down these two equations, which may be helpful to use to solve some example. For the scalar components of A along the direction B, which may be mentioned with this equation. And the vector components of A along the direction is B, it's this equation. Equation 1.34, last one, equal to A dot AB multiply with AB. Hope so this part is clear for each and every one. Okay.
Yes,
Now, is there any doubt?
No, sir.
No, sir.
So taking the example, write down this, all of you. The vector P, Q and R is given. P is equal to 2A of X minus AZ. Q is equal to 2A of X minus AY plus 2AZ. Only first two, P and Q. Find out the components of P along the Q. The scalar components of P along the Q, and same as the vector components of P along the Q. Try to solve it at your own. Use this equation. Now instead of the A and B, now it is P and Q. So what we can write down? P of Q is equal to capital P into unit vector of Q. This is the scalar component and this is the vector component. So just try to solve this. I am speaking any random number to solve this example. So everyone try to solve it. So anyone of you are getting the answer?
Sir. Hello, sir.
Can you tell me the final answer?
Sir, 0.44 AX minus 0.2 AX plus 0.4 AX, AY, AZ, I think.
Just repeat it.
0.4 AX minus 0.2 AY plus 0.4 AZ.
Okay. So 27. Can you share the whatever the example you are done? Share your screen.
Sir, actually I am using laptop, so I can't take a shot of my page.
You are using the laptop,
Yes.
but you can start your camera, na?
Yes, sir.
You can start your camera and just see how exactly you are calculated.
Yes, sir. But it can't able to see, sir. No, 1 minute. I try.
Can you take the picture and share it right now? Take a picture of your
Yes, sir.
and just connect your phone with a desktop, or you can directly share with your phone also.
Yes, sir. I have to switch on to my phone, sir. So it
Okay,
will
okay,
take.
no, you can. 31. 31 number.
Yes, sir.
Your task is completed.
Sir, still trying.
Hope so you are knowing what we have to do. May I know your name? Who is this?
Yes, sir.
Tell me your name. 31.
Ritu.
Ritu. So you are knowing what we have to do to solve this example? $59.
Yes, sir.
Getting the answer?
No, sir. Actually, I was out, so I came back when you had already closed the question.
Okay.
Yes,
So it's a
sir.
request to all. At least try to solve at your own. I'm just repeat how exactly you can find out the answer. So in this case, the two vector is given. One is P and second is the Q. Okay. And you have to find out the both the components, scalar components as well as the vector components. So what exactly you have to find out? The scalar components of P of Q. Now it is P and Q. Okay. So P of Q is equal to P dot A of Q. Now P is already known because P is vector is already given to you. Okay. Somehow you have to find out A of Q. A of Q is what? It's a Q divided by it's a magnitude of Q. So A of Q is equal to Q divided by mod of Q. Clear? So you are getting some answer in a vector form and just multiply with another vector, which is nothing but a dot product. Remember it a dot product. It means answer should be in a which form? Scalar form. So right now, this is basically a vector component. This is the vector component. They are using some different method, but you maybe go with the easiest one. Easiest one, which one? This one. If I know the only the equation, you can easily find out. So this is the scalar components of P along the Q. Okay. Whatever the answer you are getting, just multiply with a unit vector. But this is simple multiplication. Unit vector of Q. So you may be getting the answer. 27.
Yes, sir.
Getting the screenshot?
Yes, yes, sir.
You
Yes, sir.
can share
I
it
will
if
try
you
to
are
share.
getting the screenshot.
Sir, I am not able.
What?
I am not able to share the screen, sir, from this phone. Yes, now I can, sir.
You are present. Now you are presenter.
Yes, yes.
So all of you just say it how they are calculated. See, in this case, instead of this one, whatever the mechanism they are following, you will directly find out the P of Q and A of Q. Sorry, A of Q and this one. Small a of B or A of Q. Right now it is A of Q. Okay. So already I think answer is given in a book. So those who are open the book, you may be getting the answer, but try to solve it your own. Otherwise, what's happen? There's a no marks of this your whatever the methods you are following. Remember it. There is a no marks in a GTU. Suppose if your answer is wrong, definitely you may be getting the 0. So that's why there is a maximum failing ratio of this subject. If you see the past results of this subject, there are maximum failure. Okay, so try to solve at your own. Definitely you can improve your the calculation methods. So any doubt in this projection of the vector and the components of the vector? Now just change the role. 27 height. Okay, done. Any doubt in a components, scalar components of a vector and the vector components of A along the B? So already book is uploaded on a team. You can solve the example example 1.5 and practice exercise 1.5. On next lecture, I'm asking any random students, you have to solve it and you have to identify the results. Results is already given to you. You have to somehow prove it. So those who have opened this book, you may be identify. I'm just sharing the screen. So this is your practice exercise 1.5. Clear? Answer is already given over here. Somehow you have to solve it. This is almost similar to the whatever the example you are discuss right now. So like this were two components, find the components of E along the F and unit vector which may be perpendicular to both E and F. Okay, so I think both have already discussed. Like this is already discussed in I think previous lecture. You have to find out the E cross F which is the perpendicular and you have to identify it's a unit vector which may be perpendicular to both E and F. So is there any doubt for the scalar and vector components of A and B?
No, sir.
No, sir.
Okay. So I'm just repeat my word. Please try to solve at your own because right now you have a sufficient time to solve it. And this is only the maths related subject. If you see the theory, you have to also prove something. Okay. So if you are comfortable with the first vector algebra and the second part is coordinate system, it will be very easy to deal with the rest all the chapters: electric field intensity, flux density, magnetic flux density, flux, and for the consequences subject all like a antenna, maybe radar, maybe microwave. Okay, so it's a request to all, whatever the task is given to you like a practice exercise 1.5, try to solve at your own. So taking your attendance. Okay, now you may leave from this meeting.
Thank you, sir.
Thank you, sir.
Thank you, sir.